All right, welcome to lesson 4.1. This is going to be on plotting points on a coordinate plane and also performing transformations on that coordinate plane. So first, let's just review our parts of the coordinate plane. So we have our huge coordinate plane with our x-axis that goes from left to right, and then we have our y-axis, which goes up and down. We have our origin where the two axes cross over, which is 0, 0. It's if you were to plot that point. Okay, and then it also has our coordinate plane also has 4 different sections, or we call them quadrants. Okay, so we've got the first quadrant right here, second quadrant, third quadrant, and fourth quadrant. The reason there's a giant C here in the middle is that it helps you remember the order. So remember C for coordinate, and you will be able to figure it out. You always start here, go 1, 2, 3, and 4, and that's how you order them, okay? Just so you know, if while you're graphing your points, remember your ordered pairs are always X first and then Y, just like in the alphabet. Okay, X always comes first. So if I were to plot the point, let's say -3, 2, I would go -3 on my coordinate, or on my x-axis, excuse me, and then up 2, and I would be right there, okay? Now, if they were to say plot the point and then describe the location for this particular point, -3, 2, is in the second quadrant, okay? If you have a situation where you are on, let's say you're graphing 0, 4, okay? So 0, 4, so you're right here, and it asks you to describe the location. Obviously, you're not in a quadrant, but you would just say you're on the y-axis, okay? All right, so going into the meat and potatoes of our lesson today, which is about basically introducing the idea of graphing a function or a line, a linear function in this case, given a couple pieces of information. So here's our question. It says graph y equals -x minus 2. Okay, so this is our main equation. Okay, with domains -2, -1, 0, 1, and 2. Okay, and if you remember, domain means x, okay, whereas range means y, okay. A little bit of a review for you. So we're going to use the x values right here listed, -2, -1, 0, 1, and 2. And how we're going to do this is we're just going to take this x value and we're going to plug it into our equation. So if we were to take -2, plug it into my equation right here, it would be -2, minus 2, which would become 2 minus 2. So our range would be 0. Okay, go down the list, -1 minus 2, so +1 minus 2 equals -1. Keep going down. And now we have a set of 5 points to graph. These points, if you were to take this information in the middle and go, I'm going to forget about it right here. I have a -2, 0 as a coordinate point, -1, -1, 0, 0, 1, -3, and 2, -4. So if I were to graph my equation, it would look like this. If you notice, we have -2, 0, -1, -1. I don't know what happened here. 0, 0. I think this is supposed to be -2. 0, -2. 1, -3, and then 2, -4. All right, so our next example is going to be a word problem. So we have in 1920, the ratification of the 19th Amendment to the U.S. Constitution gave women the right to vote. The table shows the number to the nearest million of votes cast in presidential elections both before and since women were able to vote. So we are given this lovely table down here, okay? We've got our years before or since 1920, okay? And then we have the votes in million. Now, if you notice, it doesn't say, 1920, 1916, 1925, whatever. It actually is giving it to you in a different format. So notice that 0 is representing 1920. So then 4 years above, this would be 1924. 4 years below, 1916. 8 years above, 1928. 1932, so on and so forth, okay? So then our 3 questions to go along with this are explain how you know that the table represents a function, and then graph the function represented by the table, and then C, describe any trend in the number of votes cast. So right away when you're looking at this table, I want you guys to notice one thing. This top one is going to be your X value, and this bottom one is going to be your Y value. This is very consistent of how these word problems are going to work. Usually the top row is X, bottom row is Y, and if you were to graph it, then you would just make the X axis be the years and the Y axis be the votes. All right, so let's look at how we're answering some of these problems. So first, the first one, A, with explain how you know the table represents a function. Well, we know that a function has to have, for every input, it has to have one output. And we learned that in chapter 1, so you'll have to remember that. If you remember, we had that vertical line test. So to make sure that none of the lines are on top of each other if we go along like this. Because if you graph it and you look at it, you know right away that it is a function because none of the inputs have an output like up here. There's no points on top of each other. Okay, so A and B kind of relate to each other. That's why the solutions are on the same slide. So with A, yes, it is a function because each input has exactly one output. And then B, graphing the function. Like I said before, X is our years, Y is the number of votes cast. And we just went through and graphed the points. So for example, we have 0, 27 and 4, 29. If you look on here, we have 0, 27, 4, 29. Okay. All right, and then the last question we had is describe any trend in the number of votes cast. So if you look at the graph right here, notice a trend. Well, the trend that I noticed right away is that the votes are going up as the years go on. So it says in the 3 election years before 1920, down here, the votes cast was less than 20 million. They were really low. And then as the years went on, it went up, 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 and it probably has continued to go up as years have gone on. All right. So that is how to graph a function using both a table and using like a real world situation. Okay. The second part of our lesson today is going to be talking about something called transformations. So if we are performing transformations in a coordinate plane, it means we're just moving a point or a figure around on the coordinate plane. So when we're talking about a translation, it means that we're moving an object a given distance left or right or up and down, okay? And you can use the coordinate notation, sorry, this got cut off, to explain this. So if you look, the coordinate notation for a translation, it's going to look something like this. So if we're given a point, x, y, and then you use the arrow notation, and you say x plus some amount. So let's say my point right here is on the x-axis. Let's say this is -3, and it moves to 2, okay? This is now 2. You would say that -3 plus 5 would then be the notation to get to this +2. Same with the y, and I'll explain how to do that as we go through. Okay, so there are a couple different types of transformation or translations that we are going to be talking about. The first one is a vertical stretch or shrink. Okay, so a vertical stretch or shrink basically is making the figure either larger or smaller. Okay, there's also a reflection where you're flipping a figure. Okay, so just like I was saying before, here's this arrow notation again. Okay, so we are given a point xy, so our original is at 3, 0, and my x is staying the same, but my y is increasing by 3. That's what this y plus 3 means. So my x stays the same, 3 to 3, but my y is going to go 0, plus 3 to 3. X stays the same, 4 to 4, but my y, 2 plus 3, which would equal 5. And then the last point, 5, 0, so 5 would stay the same, but 0 would become 3. So my original figure is this blue one down here, and its image, the result of its transformation, is this red figure, okay? And it usually is labeled with the tick marks after it to show that it is, in fact, an image, okay? So then we go into our vertical stretch or shrink in type of problem and our reflection type of problem, and I'm going to show you how that works. So let's say we have a transformation where x and y, x again is staying the same, but y is being multiplied by -2. Okay, so you're just going to take your y coordinate and you're going to multiply by -2. So in this case, 0 times -2 is just 0. 2 times -2 would become -4. 0 times -2 would be 0. So in this case, two of our points, as you can see, stayed the same. However, our B point went from being at 2 all the way down to -4. This would be considered both a reflection because it reflected, but also a vertical stretch because you can see that it stretched, it got bigger. Okay. All right, so just to kind of go over those, transformations again give you a little bit of a synopsis here. If you were to just move it horizontally, okay, your x would just be increasing or decreasing if you were going left. A vertical is when your y would change, so if it's being added and it's going up, or if it's being subtracted and going down. Okay, without a reflection, if you just have where a is bigger than 0, you're not multiplying it by a negative number, then you're going to get something that looks like this, where we have just our blue figure, our original, it's just being stretched right over our original figure. And with a reflection, you are multiplying by a negative number. So we're both having a reflection and we're also being stretched. All right, so a lot of information in this video, but a lot of good information. Please make sure that you take lots of notes, and if you have any questions, please bring those to class tomorrow. Thanks.